All right, so ladies and gentlemen, we're looking at 8.3, proving quadrilaterals and parallelograms. Yes. Good question? Okay. All right, we're going to look at theorem 8.7 through 8.11. Again, the proof on the front is extra credit. 8.7, if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral must be a parallelogram. If both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral must be a parallelogram. If an angle of a quadrilateral is supplementary to both of its consecutive angles, then the quadrilateral is a parallelogram. 8.10 is if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. If one pair of opposite sides of a parallelogram are congruent and parallel, then the quadrilateral is a parallelogram. Do you guys see how this is basically the opposite of what we did yesterday?
Yeah.
So if I give you a four-sided figure, you have to use one of these to prove it is a quadrilateral. Yes?
Yep.
Okay. Let's look at this crazy graphing. Yes, do you have a question, Nathan?
Yeah, so like for the first one, it says with the opposite sides. So like
Yeah.
after we find out what they whatever the value equals and
Both pairs
stuff,
of opposite. Yeah.
plug it in and we can find out.
No, this would be the opposite way. I would give you a picture of a four-sided figure. Two of the sides would be equal to each other. You would say, it is a parallelogram because they're equal. All right. So we're going to do this crazy thing with methods. All right. This is if I give you a lovely little graph, and I want you to use three different methods to prove that this four-sided figure is a parallelogram. So our first step is we're going to have to plot these points. So we're going to plot A first. We go 2, 0. We get A. We're going to go over 3, up 4, and that's B. We're going to go -2, up 6, and we're going to say that that's C. And then we're going to go -3, up 2, and this is D, and then we're going to connect. Okay? So we need three different ways of proving that this is a parallelogram. Okay? It does have four sides. That only proves it's a quadrilateral. Okay, so let's look at the different ways to prove it. We could prove that the opposite sides are congruent, both pairs. What would we have to use in order to do that? How do we prove how long something is? Distance formula. So in order to prove that it's a quadrilateral, one of our methods is to use the distance formula. And this proves theorem 8.7. So we're going to just put 8.7 next to it, just so we remember. Okay? Both pairs are congruent. Okay.
So we don't actually have to put in the distance. Maybe we can just say that.
No, we're going to actually do it in a second, but we're going to go over the different methods first. Okay, let's look at the other side. What other ways? How about 8.11?
Can we do the points? So
Do we know what 8.11 is? Yes. We're going to figure out using slope and distance formula. We're going to figure out one pair. This is 8.11, by the way. One pair is congruent and parallel. Ugh. And we know it's parallel if it has the same what? What is this word right here?
Slope.
Yeah, there we go. Okay.
what's the one?
And there is another way to use this. Okay, you guys have a lot more space between your methods. We're going to actually do the methods in each of those spaces, but I'm going to do mine at the end because I didn't leave myself enough room. Okay, so there's one more. What does theorem 8.10 say? What do the diagonals look like?
Parallel.
Okay, the diagonals must bisect each other. So I would have to find the midpoint of C to A and D to B. Okay, so you're going to use the midpoint formula.
Can you just like draw a line and see what I mean?
No. Because if your line isn't exactly perfect, it doesn't work, which is why we use the midpoint formula, because then your drawing doesn't have to be perfect. Okay? So we're going to use the midpoint formula, and this is theorem 810. Find that the diagonals bisect each other.
That's what? 8.10?
Mm-hmm. Each other. That's supposed to be a C right there. I know it looks like an O. Yes. So if you have a four-sided figure and you have to prove this a parallelogram, you could use any of these ways. Okay. The other ways that we could use is with angles, but you can't. It's harder to figure out an angle when we have it in a coordinate plane. So these are the three methods you'll use if you have a coordinate plane. Coordinate plane is like when it's graphed. Okay. All right. So let's look at these. Let's try each method. So I'm going to use method 1. So go back up to method 1. And we're going to do 4 distance formulas.
Method line.
It's supposed to be method 1. I don't know why my computer keeps trying to connect things. Okay. So we're going to find the distance first between A and B. Have I lost anybody? Are we okay? We're doing method 1. We're going to find 4 distance formulas and see that 2 of them match 2 of the others. Okay. All right. So we know the distance formula is the square root of y2 minus y1 squared plus x2 minus x1 squared. So I'm going to just plug these in. We've got A, we've got y is 0 minus, we're looking at B, y is 4. Squared plus x is 2 for A, B is 3 squared. Okay, so then you can just put this all in your calculator all at the same time, or you can do it individually. Just make sure you put the right parentheses. So we go, I push second square root on my calculator, parentheses 0 minus 4, n parentheses squared, plus 2 minus 3, n parentheses squared, n parentheses, and I get my answer is 4.12 approximately. Okay. Now let's do the distance formula between A and C. Shall we go over, you could do this too. 4 squared, 0 minus 4 is 4. 4 squared is 16. Okay. 2 minus 3 is a negative 1. Negative 1 squared is 1. Ugh. 1. Okay, 1 plus 16 is 17. The square root of 17 is approximately 4.12. All right, but I think it's easier if you just put it all at your calculator all at once. Okay, now I'm going to go between A and C. Okay, so I'm going to take A, which is, the y is 0, minus 6 squared, plus the x, which is 2, minus the cx, which is negative 2, squared. We know this becomes positive.
We need to write all that down.
I would write down because it's going to make it easier to put it in your calculator, and you're less likely to make a mistake. So I'd be writing it down right now instead of spinning your paper. So we get approximately 7.2. Okay, 2 down, guys, 2 to go. Okay, we're going to do the distance between B and C. So this is the square root of y minus y squared plus x minus x minus x. We know two negatives make a positive. So again, just stick it in your calculator all at once. It's going to make your life so much easier if you do it that way. So you go second square root, parentheses 4 minus 6, and parentheses squared, plus 3 plus 2, and parentheses squared, and parentheses. You get approximately 5.4, we'll round to. Okay, last one. Well, already you guys, can this be a parallelogram? Or any of the two sides, or 3 out of these sides, or any of them congruent? Yeah. But we're going to do the last one just to prove it.
What if that one?
Wait, so would you suggest doing the last one then?
I would suggest doing the last one only in this case because I'm trying to prove something, not if you got to this point you could stop if you were on a quiz. CD equals the square root of 6 minus 2 squared plus negative 2 minus a negative 3. Oh. Minus a negative 3. This becomes positive. Okay, so then we plug this in. Second square root, 6 minus 2 squared plus negative 2 plus 3 squared in parentheses. And we get 4.1.
Wait, 4.12 or just
4.12. It's approximately 4.12. So here's my question. The first thing I think is 2 of these are the same. So maybe I did one of these middle ones wrong. So let's try plugging in our calculator one more time just to make sure. I'm pretty sure this was a parallelogram. So
I thought only of them have to be.
I thought only 2 of them.
no. Both sets have to be congruent to each other for it to be a parallelogram. So let's see. We've got 0 minus 6 squared and 2 minus a negative 2. So let's plug that in the calculator one more time. Second square root, parentheses, 0 minus 6. I know it's annoying when I make a mistake, but it is real life, so let's try it. So we get 7.2, so let's look at the other one. B to C. B is 4 minus 6, 3 minus a negative 2, so it's right there. Parentheses 4 minus 6 squared plus 3 plus 2 squared in parentheses. Still get 5.4. Well, I guess it's not a parallelogram. Okay, so method 1 is you would have to have 2 sets of the same answer for it to be true. Now we're going to go to method 2. So if we look up here, method 2 is the slope plus the distance. All right, let's use one pair that's already congruent. AB and CD are congruent to each other. So we've already found the distance of them. So let's just rewrite that. Yes? Is somebody raising their hand? Yes.
In our homework, they're going to tell us what method to use.
Possibly, possibly not. You might have to be able to choose. But it should be the work for all of them. Okay, so I know AB and CD are both 4.12. Let's figure out if the slope is the same. Sit up, guys. I know it's warm in here. Chance, pay attention. Okay. Yes, you can. Let's find out if the slope is the same. So I'm going to find the slope from A to B. We know the slope is y2 minus y1 over x2 minus x1?
Yeah.
So we go 4 minus 0 over 3 minus 2. And we get 4 over 1. C to D is 2 2 minus 6, I'm not sure why we're talking while I'm talking, but please stop,
What does that mean?
over